Vaishnavi from CSC NGIT, and today I'm going to present about my uh, project, which is Talqs, which is a transformer-based architecture for legal question answering and summarization. In my previous video, I told how the working is done, which is it is a transformer which can generate summaries and question answers asked by the user on Indian legal documents or Indian legal court cases. So let's get into it. So how Talqs works? Basically, when we open the app, we can see a landing page which has many options. So when we go to legal assistant, we should upload few PDF, and the chunks which are the retrieval model, which is a BERT v3 model, is fine-tuned by us and trained on legal corpus. So it chunks the text logically and embeds them into file index for retrieval. Next step, user types a legal question. After the user types a legal question, the generator, which is the Methomax L2B3, which is L213B, is generates answer using prompt plus chunks, and answer or summary is shown in the front end. We also have the option to download the PDF, as we are not storing the data between the chatbot and the user to protect their privacy. Next, let's go to the code snippets. The main code snippets from our model is the extraction part of the PDF, which cleans it, splits into smaller, meaningful chunks for processing. And next here, we can see that this code converts chunks into vector embeddings and indexes, and then using files for fast similarity search. Next, in code walkthrough, the next part is this, which is a prompt-based question answering, where it classifies the user's question into types like facts, reasoning, summaries, and based on it, it gives a retrieved answer. Next, let's go to this. It executes complete RAG workflow by handling PDF processing, chunk catching, and question classification, context retrieval, and final response generation. Next, for the deployment strategy, we are using Hugging Face Spaces to deploy our LLM models. Next, backend, we are going with Fast API, and next, we are for front end, we went with HTML, CSS, JSS, and database, we are going with MongoDB, as it was easy to use, and the output handling, summaries and answers are written via API and auto downloaded for PDF for user access. Next. Next, in the first milestone, the architecture was where a PDF was given. It gets preprocessed and then goes to two different transformers, which where one transformer would answer the question, would answer the questions asked by the legal user, and the next transformer works with summarization part. As it was a heavy load to the model, we decided not to use two transformers and went with one transformer, which is Methomax L213B. And then in the new updated milestone, we can see that when the user uploads, it goes to the chunking process and then the model training process. We for fine-tune encoder and then retriever. And next it preprocess and RAG-based question answering, and then we get the output. Say which generator model was used. As we went through many research papers, we got to know that there are many popular choices for generators, and we went through them, which from some of them, which were T5, Mistral 7B, Minitron 4B Instruct, OpenChat 3.5, and finally Mythomax L213B. In T5, the main problem was it's a huge model which needed GPU access. So as we didn't want the model to be too heavy, and the T5 was also hallucinating very much. So we went with the next model, which was Mistral 7B. Mistral 7B was a DPO version, but it was not following the prompts correctly and it was quantizable. So we went with it, but after training it very much, it was still hallucinating very much. So we went with the next model, which was Minitron 4B Instruct. It doesn't have a DPO version. DPO version means that the models can generate answer in the form of human emotions. So the Minitron 4B was following the prompts very correctly and it was quantizable, but it was a censored model. It was not a censored model and the hallucinations were high. So next one was the OpenChat 3.5. In the OpenChat 3.5, it was not a DPO version, but it was a good model because it was not too heavy. and it was following prompt very correctly, and it was quantizable, and hallucinations were also there, but not too much. But the only problem was it was a censored model. That means it censors the words in the legal documents which we do not want in a legal AI model. So finally, when we went through Mythomax 13B, we give it the retriever, and it was a DPO version. It was following prompts correctly, it was quantizable, and it was not a sensor model, and its hallucinations were very less compared to the other models. So that was why the generator model was chosen. Next. Next, the retriever model. In retriever model, we trained around four retrievals, out of which we chosen one retrieval based on scores which are mean reciprocal ranks, NDCG, MAP, and recall. In this, in legal bird, we trained using many data sets which were not at all in a good format. So there was a huge time loss to prepare the data sets. And again, we went with Google Bird based uncased, which gave an MRR score of 0.64, 0.69, 0.64, and 77, which were not at all satisfactory for a retrieval because it has an important job to retrieve the top key chunks. And next we went with the All Mini LM L6P2, which is a family of bird, and it gave us a good scores of 0.86, 0.89, 0.86, and 95, which was satisfactory, but we wanted more. So we went with Nidristi Bird V3, 0.96, 0.97, 0.96, and 100, which were very good. So we went with it. All these models are uploaded in Hugging Face. Next, the summarization and question answering model and how it works. The Mathemax N13 is an instruction queue large DPO version. It accepts structured prompts like instruction, which has answer based on type of questions. Context top chunks is given. Next, the question asked by the user is given. Next, it interprets the question using the context and generates precise answer using its legal reasoning ability. The user's question is first to which it belongs to which category, and based on that it interprets the question. It delivers accurate, conceptual, and legally coherent answers and outperforms other GPT models like OpenChat 3.5 and legal scenarios. Next, from this project we learned many things. Mainly it was about the new gen AI models which were in high demand. So we also learned about prompt designing and how much important a prompt design when giving to a Gen AI model. So next we learn about the different chunking techniques, and also output validation, and also noting the mistakes. And also we also learned that research is a very important thing before doing any model, so that we can learn from other people's mistake and not repeat it again. Next, the challenges we faced were mainly the prompt variability, because one prompt, when given to the model, is not suitable for other uh, PDF cases, which was a bit difficult to change. So, the prompt variability was a bit of a challenge we faced, and the memory management, as the models were very heavy, we couldn't use the GPU, which was limited for the day. And so there were many challenges we faced with the heavy models. So we went with the lightweight versions. Next, dataset preparation. Because the dataset preparation took very much time, because we needed to prepare many data sets so that the retrieval model can understand the main points. Next, what was achieved? Precise generation of answers for queries asked by the user, abstract to summary generation, text to speech conversation, and generation time for summary was significantly reduced than in the milestone map. Next, for the future goals, no. Next, for the conclusion part, we can conclude that our model is a fully working model, which has many features like question answering generation and summary generation, and it takes less than 2 minutes to generate each answer. So it is an accurate model, and we have the matrices given to the users to so that he or she can trust our model that it is an accurate model. For future goals, we are planning to integrate multilingual TTS, which will help people who don't know only regional languages in India. And also, we can add an avatar API which speaks out the generated output to help specially able people who can't see or have any issues with their uh, eyes. Next, to decrease the time of generation taken by model. As the generation model takes much time, 2 minutes, but it's less. But comparatively, we need a fast model. So we want to decrease the time taken by the generation of the model, and also we want to make the UI more appealing to the users and easy to use. Thank you. A walkthrough of our code where we can. So this is a live demo of our app where we have Nyayakti as our model name, and this landing page gives us a description of what our app does, and then we have here the sign-in page, the legal assistant page, about us, contact us, and research. In sign-in page, the user can sign in. If you don't have a sign-in page, we have a sign-up page too. Next, in the legal assistant page, this is chatbot where it answers questions. Next, in the About Us page, it is about the team, and the research page, it tells us what research is there, and gives the user an idea about how the model works and how it is used. That's it. Thank you. Thank you.